Welcome to a new session of control systems. In today's class, we are going to see the basic concept of signal flow graph. Signal flow graph. It is used to represent the control system graphically. It was developed by Mr. S.J. Masons, famously known as Mason's gain formula, given by T is equal to 1 by delta sigma of Pk delta K, where Pk stands for the forward path gain of gate forward path and K is equal to number of forward paths in the signal flow graph. And delta is equal to 1 minus sum of individual loop gains plus sum of gain product of all possible combinations of two non-touching loops minus sum of gain product of all possible combinations of three non-touching loops plus so on. And delta k is equal to delta for the part of the graph which is not touching kth forward path. So this basic concept of signal flow graph or the main format of signal flow graph can be easily understood by solving a given mechanical or any physical system. For example, in our previous classes, we have seen the transfer function of C of S by R of S using block reduction technique. So what was the technique? We are going to just give a revise over this particular session. So first, in block reduction technique under step 1, we are moving the branch point after G2. So this is the G2 and we need to move the branch point after G2. So this is how it is done under block reduction technique. When the branch point is moved from backward to forward, the gain of the path will be divided by the gain of the path which was before the gain of, that means the takeoff point which was before the gain point. So that is nothing but G1 by G2. Now here you can see we have just simplified the given block reduction. In fact, we have reduced the block reduction into this form and we can easily eliminate the negative feedback loop. Where is the negative feedback loop? This is the negative feedback loop that can be eliminated with the help of this formula G2 by 1 plus G2H, where this block reduction is further reduced to this form where the eliminated path is represented by this and you have the summing point followed by G3 in positive way and minus of G1 by G2. Anyhow, we can combine the blocks in series in this fashion and we can eliminate the like points like G2 and G2, and finally we are going to get C of S by R of S which is equal to G3 minus G1 by 1 plus G2H. So this is the transfer function what we have obtained using block reduction technique. You can check back our previous video how to obtain the transfer function using block reduction technique. The same problem we have discussed over there. The conclusion is that we are supposed to get the same answer using signal flow graph. So reduce the block diagram using signal flow graph and find the transfer function of C of S by R of S for the same blocks which is given in this fashion. So what we are going to do is, first we are going to identify the uh, node points. So wherever you have the branch point, the summing point, the input and the output, I am taking the values in the name of nodes. So here R of S is node A, the summing point 1 is node B, the takeoff point 1 is node C, and D is another node point where you have the common connection of G2 and G3, and again you have a node which is again having a feedback path of H and is going to the summing point. This frames another node and you have another summing point that we are identifying as node E, and finally the output C of S as node F. Okay, so for the given blocks I can form a graph like this. So first I am identifying the node points from starting to ending from A to F and all the branch points, and the summing points are given by B, C, D, E between A and F. Then I have a feedback loop of H, and the forward paths given by 1 and 1 wherever I have, for suppose from A to B, I don't have any uh, forward path representation, so I'm representing it by 1. In fact, Masons has given us the idea of taking the path value as gain as value 1. From B to C, again 1. From C to D, it is given as G2, the gain G2. From D to E, we have gain G3. From E to F, we have the gain as 1. And you can see from point C to point E, we have another gain whose value is minus G1. So this is the signal flow graph which we have obtained from the given blocks. So inputs are input is R of S, output is C of S. Fine. Now Mason's gain formula is given by 1 by delta sigma of Pk delta K. We have seen already what is Pk and delta K, where K represents the number of forward paths. So we have here two forward paths. What are those two forward paths from input to output? So a forward path is a path where you have a starting point, you have an ending point, and you don't have a feedback path. So first you can see from node A to node F, we have a forward path which is given by 1, 1, G2, G3 and 1. Hence, P1 will be equal to G2, G3 multiplied with 1s. So it will be nothing but G2 and G3. And the next forward path is nothing but it is starting from A, B, C, and it is jumping from C to E and going back to F. Sorry, it is going forward to F. So that forward path in terms of minus G1, it is nothing but minus G1. So this is P1 and P2. Fine. Now individual loop. So from the given graph, we have only one loop. What is that loop? Starting from B, going to C, going to D and coming back to B. So that is nothing but minus H, and from B to D we have G2. So the path is nothing but minus G2H minus because of minus H. And delta 1 is equal to delta for the part of the graph which is not touching first forward path. That is nothing but 1 minus 0. Similarly, second forward path has a delta for the part of the graph which is not touching the second forward path, that is equal to 1. So in fact, delta will be equal to 1 minus the sum of individual loop gains, which is nothing but 1 minus of this P11. This becomes minus G2H, and total transfer function will be equal to 1 by delta P1 delta 1 plus P2 delta 2, which is nothing but 1 by delta value here we got as 1 plus G2H, and P1 is G2 G3, delta 1 is 1, and P2 is minus G1 and delta 2 is 1. So overall the transfer function is nothing but G2 G3 minus G1 by 1 plus G2H. So this is the same answer what we got using block reduction technique. Okay, using block diagram reduction technique, find the closed loop transfer function of the system whose block diagram is shown below. In fact, if at all you look into our previous block reduction technique problem, I have asked you to calculate the transfer function C of S by R of S using block reduction technique. Anyhow, we'll solve this problem using block reduction as well as signal flow graph. And in the problem, it is also asked that check out the transfer function using signal flow graph. Okay, fine. So first, we'll go with the solution using block reduction technique. So moving the branch point, that is takeoff point before G2. Where is G2? This is the G2. Okay, we need to move the branch point before G2. So this is G2, and we need to take this branch point and we need to place before G2 like this. So in the diagram, you can see in the block reduction, I've shifted the point from this to this in this fashion. Whenever this process is done, the path H1 is getting multiplied with the gain G2. This is one of the principle of, or one of the rule of block reduction. Okay, this is done. Then adding blocks in parallel, you can see G3 and G2 are in parallel. You can add them easily. And moving the takeoff point after block G2 plus G3. Okay, so we have added these two blocks like this, and we are going to shift the takeoff point from left of block G2 plus G3 to the right of block G2 G3 like this. So we have taken the takeoff point before G2 plus G3 to after G2 plus G3. In fact, the main principle involved here, that is the rule, that is nothing but the path which is selected, it gets divided by the block G2 plus G3 in this fashion. Fine. Now you can see this block reduction has a feedback loop of H2, then has a feedback loop of unity. In fact, G1 becomes in series with this block, which is nothing but the feedback loop. And then you have the entire G1 combination of G2, G3, and H2. That entire unity feedback goes to one value, and that value has the feedback with this final H1 G2 by G2 plus G3. So eliminating the feedback loop first and coming the blocks in series. So nothing but this G2 plus G3 with feedback H2 can be obtained as G2 plus G3 by 1 plus H2 of G2 plus G3 multiplied with series of G1. So this results in G1 of G2 plus G3 by 1 plus H2 of G2 plus G3. I hope you understood this step. This is very simple. Don't panic. It's a simple calculations we have done over here using block reduction technique. After this, you can see we have this replacement over this block, and you have a unity feedback. So eliminating unity feedback loop, that is this particular feedback, can be obtained with the help of G by 1 plus GH, where H stands for 1, G stands for G1 of G2 plus G3 by 1 plus H2 of G2 plus G3. Anyhow, this simplification leads to this value, that is G1 G2 plus G1 G3 whole divided by 1 plus H2 G2 plus H2 G3 plus G1 G2 plus G1 G3. So I'm taking the above block reduction to this form, where the main G value will be nothing but the numerator block, and H value is nothing but the denominator block. Again, with the help of the concept of eliminating feedback loop, we can remove this particular block to G by 1 plus GH, where H is nothing but H1 G2 by G2 plus G3, and G you have this numerator block. So this simplification leads to the final answer as G1 G2 plus G1 G3 by 1 plus H2 G2 plus H2 G3 plus G1 G2 plus G1 G3 plus H1 G1 G2. Fine. This answer what we got is from the block reduction technique. Now we need to get the same answer with the help of signal flow graph. So same diagram we have taken, and now we are going to employ the signal flow graph. So first I have identified the nodes. You can see R of S is input and denoted by node A, and C of S is the output denoted by node H. In fact, node H, node I, and node J are all the common node points. Okay, now first I am taking the nodes which are ranging from A to H and from H to J like this, and I'm naming the nodes as A to J like this. Then the gain between node A and B is 1, between B and C is 1, between C and D is G1, between D and E is 1, between E and F it is G2, between F and G it is 1, between G and H it is again 1, same as between H and I and J. Fine. Then uh, you have a branch G3 starting from node E to node G in positive way. So that is shown in the signal flow graph. And you have from F to B, which is minus H1. Fine. Again from I to D, you have minus H2, right? And finally from J to C, you have minus 1. So this is how we can draw a signal flow graph from the given blocks under mechanical system or physical system. I hope you understood this step. Once this is done, it is very easy as us to find out the transfer function using signal flow graph. So this is the graph that we have drawn from Mason's gain formula. T is equal to 1 by delta sigma of pk delta k. Now clearly we have here two forward paths. Forward path is a path which starts from one node and it ends at another node without feedback path. So number of forward paths are 2. The forward path gains are nothing but P1, which is given by G1, G2, because 1 is multiplied with G1 and G2, the value is 1. Similarly, another forward path starting from node A to J and overlapping node F, and you're going to get the value of P2 as G1, G3. Done. Now finding out the individual loops. So loop gains of individual loops is nothing but first you find out the loop 1. You can see starts from B, goes to F, come back to B. So the value of loop 1, that is denoted by P11, is nothing but minus G1 G2 H1. Then you have P21, which is nothing but minus G1 G2 starting from C, going back to J, coming back to C. Then you have P31, which is nothing but minus G2 H2 starting from D, going back to going back to I, coming back to D. P41 starting from D, going back to H, I, and again back to D, overlapping F. So the gain value of that is minus G3H2. Similarly, P51 is another loop gain, starts from C, goes to E, overlaps to G, go back to H, come back to J, and again come back to C. So we have identified all the individual loops. Now gain products of two non-touching loops. If at all you observe forward path gain 1 or forward path gain 2, there are no possibility of 2 or 3 non-touching loops. Fine. So now we can calculate the delta value and delta k value, where delta is equal to 1 minus the sum of the individual loops. Already we have taken all the individual loops. We have 5 individual loops. So 1 minus of these 5 individual loops, we are going to get the value of delta is equal to 1 plus G1 G2 H1 plus G1 G2 plus G2 H2 plus G3 H2 plus G1 G3. So there is no part of the graph which is non-touching with the forward path 1 or 2. Finally, delta 1 is equal to 1, delta 2 equal to 1, and finally T equal to G1 G2 plus G1 G3 by 1 plus G1 G2 H1 plus G1 G2 plus G2 H2 plus G3 H2 plus G1 G3. So this is how you find out the transfer function. So if at all you like this video, share among your friends, subscribe to this channel and press the bell icon for the future notifications. Thank you.